let's go ahead and get started with the problems for today. Numbers 1 through 4. The directions say to determine whether the equation represents y as a function of x, okay? So remember, we've talked about y as a function of x means you get y all by itself, okay? And then you see if each input has one output, y as a function of x. So let's get y all by itself, okay? We have negative y to the fourth equals negative 16. By bringing the 16 over and making it negative, divide by a negative 1, y to the fourth equals 16. And now, whenever we're going to take the fourth root of both sides. The fourth root of y to the fourth is y, and the fourth root of 16 is 2. Now remember, whenever your index is even right here, okay? Square root, fourth root, sixth root, eighth root, 10th root, etc. You must put a plus minus right here, okay? So if you'll look here, and by the way, there should have been x right here, sorry about that, and there should be an x right here. We would have this right here. Sorry about that mistake there, okay? Now, do you see what I've done? Please listen to me very carefully, students. If this would have been a plus sign right here, or a minus sign, then you have two terms. You could not take the fourth root of 16. You'd have to leave the whole thing under the radical. But because it's one term, you can take the fourth root of just the 16 and leave the x under the radical. So the fourth root of 16 is 2. So we cross that off and put a 2 on the outside. And how do I know that? Because 2 times 2 times 2 times 2 is 16. And the fourth root of x stays here. Now, whenever you take the fourth root of something, you must put a plus minus in front of it. So, this equation does not represent y as a function of x. Because if I put a number in for x, I'm getting out two answers. Let me give you an example, okay? If I put 81 in for x, the fourth root of 81 is 3, I think. Yes, 3. And then I would get out a positive 6, and I would get out a negative 6. So I put 81 in, and I got out 6, and I got out negative 6. So this input had two outputs. No, not a function. Number 2. Okay, let's get y by itself. I'm just going to move the y over. It'd be a lot faster that way. So 2x, negative 3 equals a positive y. Now guys, this is totally a function, yes. I mean, every value that you put in for x, you're going to get one equation out, one value out for y, okay? Every input, I mean, think about it. I don't care what number you put in, you will get out one y value. Okay, yes, this is definitely y is a function of x. Okay, moving on to number 3. Now the first thing you might notice here is, Mr. Earhart, we have a square root, which is a 2 right here. So, there should be a plus minus here. No, hold on guys. You only put plus minus, listen to me, when you choose to insert the root, the square root, the fourth root, the sixth root, etc. And we did not choose to insert this. It was already here. Okay? Since it was already here, you do not put the plus minus. Now, if the plus minus had been there in the original problem, then we would say no, this is not a function, because every value you put in for x, you're going to get two values out for y. But since there's no plus minus here, then yes, this is definitely written as y as a function of x, because every value you put in for x, you will get out one value for y. Okay, moving on to number 4. Okay, now, this is interesting here, guys. This is probably one of my favorite problems in the review sheet. It's a really good thinking problem, okay? So, here we go. When you look at this, you say, oh, Mr. Earhart, no matter what value I put in for x, I'm only going to get one value out. Well, let's make sure you're right, okay? Let's put 5 in for x. So the absolute value of y equals 5 plus 2, okay? So what did you put in for x? 5. let's see if you get out one output, or if you get out more than one output, okay? Now 5 plus 2 is 7. Now I have a question for you. What is the value of y? If you have the absolute value of y equals 7, what could y equal? Well, y could be 7, because the absolute value of 7 is 7. But guys, what else could y be? Negative 7. The absolute value of negative 7 equals 7. That's true, because 7 equals 7. So when you put 5 in for x, there are two y values you get out, 7 and negative 7. This is really kind of a tricky problem, but hopefully, as I've explained it this way, it makes sense. So, what you would do is put a value in for x, get this value out here, and then you just gotta do a little thinking on your own and say, okay, the absolute value of y, could I put more than one, would there be more than one value here? That gives me out a 7, and the answer is yes. This ordered pair right here satisfies the equation, and this ordered pair right here satisfies the equation. Okay, alright, so no, not a function. This input gives you two outputs. In fact, every input will give you two outputs except one value. What would that value be? Negative 2, because negative 2 plus 2 gives you a 0, and the absolute value of y would give you out 0. So that's the only value that doesn't give you out two outputs, okay? Alright, moving on quickly to numbers 5 and 6. We are going to evaluate the function at the indicated value. Okay guys, I'm going to move pretty fast here, so here we go. We're going to put a 2 in for x. So f of 2 equals, where the x is, I put a 2. And of course your answer is 5. F of 2 equals 5. Alright, it's going to be negative 4. F of negative 4 equals, where the x is, you put negative 4. Negative times negative is positive. 16 plus 1 is 17. F of negative 4 equals 17. Alright, moving on to the next one, t squared. Everywhere there's an x, we're going to put t squared. So t squared to the second value. T squared for x squared. That's going to give you t to the fourth value plus 1. Times 2 is 4. You do not add them, you multiply them. Moving on to the last one, negative f of x. Now, this is a notation that means you're going to apply a negative sign to the entire function. If it would have looked like this, that would be notation telling you to put a negative sign for every x, okay? But that's not what we have. We have this right here. So what it means is everywhere there's an x like this, put a negative sign, and then put the entire function like this. Negative sign goes to the entire function, so your final answer would be negative x squared minus 1. There we go. Pretty simple. I applied a negative sign to the entire function. Okay, moving on to number 6. Alright, here we go. Okay, f of 8 equals, everywhere there's an x, I'm going to put an 8. Okay. So we have 8 to the 4/3 power. Now, hopefully you remember what this means. That means the cubed root of 8 to the 4th power. Okay, now, you're welcome to use a calculator if you want to. You would hit 8, then arrow for exponent, then parentheses, 4 divided by 3, close your parentheses, okay? But I'm going to break this down and show you how to do it without a calculator, in case you ever need to. You may take 8 to the 4th power first, or you may take the cubed root first. Either way is fine. Well, the cubed root of 8 is 2. 2 times 2 times 2 is 8. So the cubed root of 8 is 2. Then bring down your 4th power. acceptable. Or if you wanted to, with a calculator, you could take 8 times 8 times 8 times 8, enter, then take the cube root of that big number, and you'll still get 16. Alright? Okay, moving on to letter B, t plus 1. Alright? Now, there's really not going to be a lot you can do for this one, guys. Where the x is, I'm going to put t plus 1. So t plus 1 to the 4/3 power. That's it. I mean, a lot of students want to do this. They want to take this and take the 4/3 and multiply it through and get t to the 4/3 plus 1 to the 4/3. And then 1 to any power is just 1. So t to the 4/3 plus 1. And that is completely incorrect. And the reason is what I mentioned to you earlier back on one of these other problems when I told you back here. If I can find it. Right here, when you had one term, you could take the 4th root of it. But if you had 2 terms, then you could not take the 4th root of it, okay? Well, same thing here. You have 2 terms, so you cannot take the 4th root or anything like that, or the 3rd root, whatever, of this expression. Okay, you can write it like this if you want to. I have no problem with this. That would be fine. And I guess the more that I see this, you could put a 3 here times t plus 1 to the 1. That's really going overboard, but you could do that. And then because these two parentheses are multiplying, the cube root of t plus 1 to the cube root would be t plus 1 on the outside. Cube root of t plus 1, you could do that, and that is totally legitimate. I would not do that. This is totally acceptable, and that's also what the back of the book has, okay? Alright, moving on to letter C. Alright, first of all, we're going to start off with g of 8. Got it? G of 8. We already know what that is, don't we? G of 8 is 16. So right here, I'm going to put a big fraction. G of 8 is 16 minus g of 1. So put a 1 in for x. Well, guys, 1 to the 4/3 power is just going to be 1. 1 to any power is just going to be 1. But I'll show you if you want to see it. 1 to the 4/3 is the cube root of 1 to the 4th power. 1 times 1 times 1 times 1 is 1, and the cube root of 1 is 1. So 1 to the 4th, you can use a calculator also. 1 to the 4/3 power is 1. And then we have 8 minus 1, which is 7. 16 minus 1 is 15. So we're getting 15 over 7. Okay, 15 over 7. And then lastly, g of negative x. That means everywhere there's an x, we're going to put a negative. So here's my x. Be sure to put a parentheses. So parentheses, negative x to the 4/3 power. Okay, now let's break this down, okay? I have the cubed root of negative x to the what power? 4th power, okay? Now, having said that, if I take negative x times negative x times negative x times negative x, that gives me a positive x. Negative x times negative x times negative x times negative x. Negative times negative times negative times negative is positive. So your final answer would be this right here. Or if you wanted to write it like this, that's fine also. Either one of those two answers, okay? That's it, guys. Moving on to number 7. Let me get a drink here real quick. Number 7 through 10, they want you to determine the domain of the function. The directions also say to verify with the graph. If you want to type these into your calculator and get a graph out, that's fine. I'm not going to worry about that. I mainly want you to be able to look at an equation and figure the domain. Okay, now the domain for this is going to be tricky, obviously, because we have a square under a square root. Okay, so first of all, we're going to take 25 minus x squared. Now, if there was not an x squared, students, you you would just say the inside has to be what? Greater than or equal to 0, right? You can never take the square root of a negative number, so all of this has to be greater than or equal to 0. You would then solve this, bring the x over and make it positive. Take the square root of both sides. Or not the square root, sorry. You'd be finished. So x is less than 25. So there's your domain. That's so easy to do when there's not a power right here. But unfortunately there's a power right here. So here's what you do. You take this and set it equal to 0 and solve. This will give you critical values. Take the square root of both sides. So remember what to do. We've talked about this before. On a number line, we put a negative 5 and a positive 5. Now, because, well, these are the values here that give you 0. Negative 5 and 5, okay? If you don't believe that, go ahead and put negative 5 in for x, or put positive 5 in for x, and you'll see you get out 0. Listen to me, students, please. That is why I'm closing these points. They are not open, they are closed. They are shaded in, because if these values here give you out a 0, can you take the square root of 0? Most definitely. Most definitely. So these values here are good. Now what I've taught you to do is you check each region. 1, 2, 3. Now I'm going to check, obviously in this region here, I'm going to use negative 6. I mean, you can use a negative 1 million if you want to, but negative 6 is the easiest one. Here I'm going to test an easy number called 0, and here I'm going to test 6. So let's put negative 6 in and see what happens, okay? 25 minus x squared equals, oh, my bad, sorry about that, 25 minus, and then negative 6 squared. Let's see what we get out. 25 minus, negative times a negative is positive 36. 25 minus 36 is negative 11. I don't want to get out a negative number because I cannot take the square root of a negative number. I did get out a negative number, so this region does not work. Alright, let's test 0 now, very quickly here. Alright, 0, well, let's do that in your head, guys. 0 squared is 0, 25 minus 0 is 25. That checks. Now let's test 6. Well, trust me, you're going to get the same thing you did over here. I mean, 6 squared is 36. 25 minus 36 is negative 11. This region does not work. So here is your domain right here. So there's 3 ways to write it. You can say x is all real numbers. You can use words between positive, negative 5, inclusive. Or you could say, you could use interval notation, bracket, negative 5, comma, to positive 5, bracket, because it's inclusive. Or you could use inequalities, bring down your negative 5, bring down your 5, put an x in the middle, and write it like this. Any of those ways are okay. Okay, moving on to number 8. Alright, this is pretty simple. 3x plus 4. There's absolutely no problem with putting any value in for x that you want to, okay? You can put anything in for x. Negative, positive, fractions, decimals, whole numbers. So the domain is simply all real numbers. Or you could say x is less than or equal to 0. Or it's greater than or equal to 0. I guess say do it with inequalities. Or with interval notation, it would be negative infinity to positive infinity. You always use parentheses with infinity. Okay. Alright, moving on to number 9. Now, be very careful. We have a fraction. You understand that. You can never have a 0 in the denominator. Other than that, I see no problems with this function. You can put anything in for this x up here at all. Anything, it doesn't matter. So, I'm going to find out what makes this denominator equal to 0, okay? So I'm going to take this denominator, set it equal to 0. I'm going to find out what makes this denominator become 0. Well, you can factor it. What two numbers multiplied together give you a negative 6. One added together give you a negative 1. Well, I'm thinking of these two numbers here. When you multiply them, you get a negative 6. When you combine them, you get a negative 1. So is all real numbers except those two numbers, negative 2 and 3. So I'm going to get a number line up here just to help me see it, okay? So negative 2, positive 3, open point here, open point here. So all of these numbers work. All of these numbers work. All of these numbers work. So if you're going to use words, you would say all real numbers such that x does not equal negative 2 and 3. Okay? If you're going to use interval notation, you would say negative infinity, because it goes on and on. Negative infinity all the way to negative 2, but it's a parentheses, doesn't include negative 2. Then it goes from negative 2 to 3, parentheses, and then it picks up after 3 and goes on to positive infinity. So there's interval notation. If you want to use inequalities, you would say x is less than negative 2. And then for the next one, put an x right in the middle right here. Bring down your negative 2. Bring down your positive 3. Point the arrows to the left, but do not put equal signs right here. Do not do that. So x is greater than negative 2 and less than 3. And then you say x is greater than 3. Any of these answers is sufficient, okay? Number 10. Let's see. Alright, now, again, guys, I mean that you can put, I know it looks a little confusing with the absolute values, and I want to encourage you guys to think, okay? But there's just nothing, I'm going to use a double negative here, there's nothing that you cannot put in for t. I mean, you can put negative numbers in. You can put positive numbers in, fractions, decimals, anything. So I'm not going to write all this out for you. I'm going to go back to here, and number 10 is the same as number 8. You can put all real numbers. And this here is pretty unorthodox. I don't think I've ever seen this, but if you want to use inequalities, that's fine. Interval notation, that's pretty standard to do it this way. To do it this way or this way is pretty standard, okay? So number 10 is those answers right there. Okay, moving on to numbers 15 through, let me look here, 15 through 18. Use the vertical line test to determine whether y is a function of x. So here we go. Is there anywhere at all that you can draw a vertical line that intercepts the graph in more than one place? No, there's not. So the answer is, I better not put the word no, I'm going to confuse you. The answer is yes, it is a function. Every vertical line you draw will intersect the graph in one place. Number 16, same thing, guys. I know it does a low curve thing here, but it doesn't matter. Any vertical line that you draw is going to intersect the graph in one place. So the answer is yes. It is y is a function of x. Number 17, obviously no. There's many vertical lines you could draw that would intersect the graph in more than one place. So no, number 17 is not a function. Number 18, obviously no. There's plenty of places where you can draw a line that intersects the graph in more than one place. Now you only need one place, okay? If you get a graph that looks like this, and it goes back and then forward, and there's one place where you can draw a vertical line that intersects the graph in more than one place, then the answer is no, it's not a function. It only takes one place where you can draw a vertical line that intersects the graph in more than one place. But in this problem here, we have quite a few of them, but the answer is no, obviously it's not a function. Okay, moving on to 19 through 22, find the zeros of the function, okay? So, I'm going to put 0 in for y. Y, of course, is f of x. And now I'm going to quickly find the zeros, okay? I'm going to try to factor if at all possible. And here we go. You have a lead coefficient of 5. 5 times negative 1 is negative 5. Now, let me get a drink here real quick. Okay, students, here we go. 5 times negative 1 is negative 5. What two numbers multiply together give you negative 5? One added together give you a positive 4. Well, I'm thinking of positive 5, negative 1. If you multiply those, you get negative 5. If you add those, you get positive 4. So I bring down my first term. Bring down my last term. And then put a positive 5x and a negative 1x from these two numbers here. Now, pull out an x, and I'm left with 5x plus 1. Pull out a negative 1, and I'm left with x. And this is incorrect, and I apologize. We're going to pull out a 5x, actually, because both terms have a 5, and you're left with x plus 1. Pull out a negative 1, and you're left with x plus 1. If you want to check that, feel free to. You would take 5x times x is 5x squared. 5x times 1 is 5x. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. Okay, write your matching parentheses once. And you're left over with 5x minus 1, okay? Take this group, set it equal to 0 and solve, you'll get negative 1. Take this group, set it equal to 0 and solve, and you'll get 1/5. So these are the zeros. Now they asked you to find the zeros of this function. That's the same thing as saying what? Find the x-intercepts. So the zeros or the x-intercepts of this function are negative 1 and 5. Okay, number 20. Same thing it looks like to me. We're gonna try to factor this if we can. So 3, put a 0 in for your y right here. 3 times 21 would be 63. Now students, I need a positive 63, so I'm thinking negative 7, negative 9. If you multiply those, you get 63. If you combine those, you get negative 16. So 3x squared minus 7x minus 9x plus 21. Okay, so pull out what's common in your first two terms. 3x minus 7 is what you're left over with. Here, whenever your first term is negative, you pull out a negative. What number goes into 9 and 21? 3 does. So you're left with 3x minus 7. Check it really quick. X times 3x, 3x squared, x times negative 7, negative 7x, negative 3 times 3, negative 9, negative 3 times negative 7, 21. Write your matching parentheses once. Bring down your x minus 3. And here we go. Take this parentheses set equal to 0 and solve. You'll get a positive 7/3. Take this parentheses set equal to 0 and solve. You get 3. So if you were to graph this function, the x-intercept, the graph would cross the x-axis at 2 1/3, which is 7/3, and would also cross the x-axis at 3. These are your zeros or your x-intercepts. Okay, number 21. Let's see here. Okay, now think about this for a second, students. Put a 0 in for your f of x, okay? Now, I don't want this fraction, so I'm going to multiply both sides by 11 minus x over 1, okay? Now, if you multiply that by this side over here, anything times 0 is 0. Over here, this would cancel with this, leaving you with 8x plus 3. Now bring your 3 over and make it a negative 3. Divide by 8. And there's your 0. Just that simple. It looks really tough when you look at the problem at first, but it's really not that difficult to do. So here's the 0 or the x-intercept. Okay, moving on to 22. Well guys, we should be able to do this pretty quickly. Put a 0 in for your y. We know how to factor a 4-termer. Pull out what's common in the first two terms. Pull out what's common here, negative sign, because this is negative 25, and you're left with x minus 1. Check it real quick. Multiply this through, you will get this. Multiply negative 25 through, you will get this. Write your matching parentheses once, and you're left over with this. Now, set this equal to 0 and solve, and you'll get 1. Set this equal to 0 and solve, and you'll get positive negative 5. I'm gonna do this one for you real quick. X squared minus 25 equals 0. Bring the 25 over and make it positive. Take the square root of both sides. You're choosing to put in the square root, so you must put plus minus. So there you go. So this problem here has 3 x-intercepts or 3 zeros, 1, negative 5. All right. Moving on to number 23. 23 through 26 says, use the graphing utility to graph the function and approximate the intervals over which the calculator. Maybe you do not, so I'm going to show you just to make sure, okay? First of all, you're going to type this into your grapher, so hit the top left button, the y equals button right here, okay? Hit that, okay? Now next, you want to put an absolute value, okay? So on your screen right now, you should have y equals. Well, I think it says y subscript 1 equals. Okay, we're going to enter it right here now. Listen to me carefully. You should be on the screen right here, okay? Hit your math button. Now that's the left column. Third or fourth button down, you'll see the word math. When you hit your math button, across the top, you're going to see some options. You're going to see math, numbers, CPX, PRB, okay? This is CPX right here. You want to scroll over so numbers is highlighted, okay? Now when you do that, you're going to have options going down. Notice option number 1 says ABS. That's absolute values parentheses. So hit number 1 or scroll down and hit enter on number 1. When you do that, this will pop back up on your screen. It should say this. Go ahead and type in x plus 2. Then close your parentheses. Then hit minus. And now you want another absolute value. So go back to numbers, or go back to math, hit your math button, then scroll over to numbers, then scroll down to 1, hit enter, and this should pop up. Then you type x minus 2 and close the parentheses, and that's it. That's all there is to it. If you have any questions on that, call or email. Okay, go ahead and hit enter, and when you hit enter, you should get a graph that looks something like this. I'm in a standard normal window, okay? And let's see, my graph is -2, 1, 2, 3, 4. It looks like it does say in the directions to approximate. So here it looks like to me, and here it looks like to me. So the graph goes like this, and then goes straight, and goes straight. So you read it from left to right, and remember, you always use the x values. Please, students, use the x values or you're going to miss these, okay? So it's constant. It's constant from -infinity all the way to here, which is equal with -2 on the x-axis. So it's constant from -2, -infinity to -2, okay? It's increasing. It's increasing from here to here, from -2 to +2. Remember, whenever you're doing increasing or decreasing or constant intervals, always use parentheses, always, no matter what. So -2, +2, and then it's constant again, and it's constant from +2 to infinity. There we go. Not too difficult, okay? Alright, let's go on to number 24. Okay, we're going to type this into our grapher, so go ahead and clear out the other equation. Go ahead and hit y equals, and then put a parentheses, hit x squared, then -4, then close your parentheses, and then hit squared, okay? Give me just about 10 seconds to do that real quick here. Okay, x squared is -4, close the parentheses, squared. And it looks like you're getting kind of a W shape. Alright, now if you're on a standard window. Okay, students, I had to pause the video. I'm back now. Guys, you should have got a W-shaped graph now. On my window, this is a standard window. The top of the W is being cut off. It looks like this. It comes down, comes up, then it disappears, then it picks up here and goes like this. So I went ahead and raised my Y window to a higher positive value. So if you'll push your window button, scroll down to the Y maximum. I made my Y maximum 20, and once I made my Y maximum 20, the entire graph fit. Now it looks like it's hitting at -2 right here. It looks like it's hitting at +2 right here. And then I really don't care how high it goes, because remember, guys, do you use the x values or the y values when you're doing intervals? Well, you use the x values, so it really doesn't matter where this graph is on the y-axis as in terms of intervals, okay? So we hit this, we go up, And there we go. So, guys, going left to right, it's decreasing at first. And it's decreasing from negative infinity to negative 2. Now, students, I'm going to go ahead and kind of mark this off. So we took care of that part of the graph. Now from here to here, it's increasing. So I'm going to come over here and put increasing and use the x values. It's increasing from negative 2 to right here, which is equal to where on the x-axis 0. So negative 2 to 0. Okay, so I'm going to cross this off. Now it's decreasing from here to here. So it's decreasing from, well, it's equal with 0, and it ends at 2, so it's decreasing from 0 to 2. And then it's increasing over here from 2 on up to infinity. So there we go. Okay, moving on to number 25. Number 25. Let's quickly type this into your graphing calculator. Hit y equals, then you hit 4, then x, then arrow, then 3, minus x, then arrow, then 4. Let me quickly type that into my calculator. And let's see what we got here. 4x to the third power minus x to the fourth power. Okay, hit graph on that, and let's see what we get. And I'm getting some weird stuff. It looks like this. I'm going to try to draw it quickly. It comes up, then right here it kind of does a little flattening thing, then it goes off the screen, and then comes back down and goes like this. So I'm going to change my window to a positive, my y to a maximum 30. See if that does anything for me. Yes, it does. So now I can see the whole graph on my window. Now my only problem is it's really hard to see what it's doing right here. I mean, it could be really flat. It could even be doing this, guys. You'll be surprised how these polynomial graphs would do a little curve like that and you can barely see it. So I'm going to change my window to negative 2, positive 2, negative 2, positive 2. So the whole graph is focused on here. It'll stretch the graph out. So go to your window, put your x minimum negative 2, your x maximum 2, your y minimum negative 2, your y maximum 2, and hit graph. And it should really stretch it out for you. Okay, guys, if you'll do that, it looks like it flattens out here, but it really doesn't. Okay, it's gonna. I was mainly trying to see if it did a little curve, a little loop-de-loo right here, but it's not doing that. So it does not completely flatten out. It looks like it does, but it's still constantly increasing. So it is increasing from here all the way to here. Okay, it is. So I'm gonna go ahead and put my window back up there that I had. I'm going to make my y maximum back to 20, and as always my calculator just froze up, so I'm going to pause this and pull out the batteries. I'll be back in a second. Okay, students, I'm back now. If you'll look at your graph at this point here is equal with 3, so 1, 2, 3. Okay, so we're going to have an increasing interval from here all the way, even though it does a little a little kind of slide here. It's still going all the way up there. It's increasing from now this point here. I shouldn't have put a point right here. Sorry, it continues on. So it's going to be negative infinity to positive 3, and then it's going to decrease from positive 3 to infinity. There we go. Okay. All right. Moving on to 26. All right. This will be interesting how we're going to type this into our calculator, and I'm not quite sure how we're going to do it. Let me figure this out here. Okay, students, I think I got this figured out. Go to your y equals button, and now watch very carefully. First, you want a cubed root. Okay, so go to math, hit math, and when you hit math, look at option number 4 is cubed root. So hit enter on option number 4. Now, students, once you hit the option number 4 on your computer, on your graphing calculator, this will pop up on your screen right here. Cubed root, like this with a parentheses, okay? Do you see that? Okay, we'll go ahead and type in x, and then hit another parentheses. It's okay to do that. And type x plus 3. Then close the parentheses, then hit squared, and then put another parentheses, because you have to tell the computer where you're ending your cube root at. If you do that and hit graph, you'll be good. Now the graph looks something like this. It comes up, does a little loop-de-loop like this, and then continues like this upward, okay? Now, you should see that on your screen. Okay, I went back to a standard window with -10, +10, -10, +10, and this is kind of what you'll see. So, here's the y-axis, okay? And here's the x-axis right here. Looks something like that. Now, this is supposed to be at -3, I believe. So, 1, 2, 3. That's -3 right there. Of course, this is at 0. This low point right here. This low point is supposed to be right at -1. If you look on your graphing calculator, that's where the low point takes. That's where the low point takes place until it starts to go up again. Okay. Okay. So here we go. From left to right, it's increasing. So we have increasing. That's pretty obvious. Here to here. So we're going to put -infinity to -3. Now look, it decreases from here to here. It bottoms out right here at -1. So, decreases from -3 to -1. Those are the x values, -3 to -1. And then it starts increasing again from -1 to infinity. Okay, I know it does a little kind of slide thing here, but it still doesn't, it does not quit increasing. Okay, it continues to increase. So there we go, guys. Work on these, and hopefully you're getting them, okay? Numbers 27 through 30, we're going to write linear equations. I'm going to go really fast through these. This is Algebra 1, guys. Algebra 1. Very simple. Okay, let's find the slope. Well, first of all, here's our ordered pairs. You put in 2, you got out -6. You put in -1, you got out 3. So the slope is y. Y minus y. X minus x. -9 over +3. So your slope is -3. Okay? Now, to find your b, we use y equals mx plus b. Choose one of these points. It doesn't matter which one. I'm going to use this one. Where the y is, I'll put a 3. Where the m is, I'll put -3. Where x is, I'll put -1 plus b. So next would be, I'm going really fast. I'm being sloppy, guys. I'm not going to try to go slow on this. Negative is positive. Bring the 3 over, make it -0 equals b. So you know what the slope is. You know what b is. So your equation is y equals -3x plus 0. You do not need to put the plus 0 if you do not want to, okay? I went pretty fast. Let me check the back of the book to make sure it's accurate. And it is. We're moving on. Number 28. Okay, your ordered pair is 0, -5. Your ordered pair is 4, -8. Slope is y minus y. 5 minus a -8. 0 minus 4. You would get 13 over -4 for your slope. Alright, now, I think I made a mistake somewhere because, yeah, this should be a -5. This should be a -5. So this should be a +3. Sorry about that. So your slope is -3/4. Now to find your b, we have y equals mx plus b. I'm going to use this point right here. So where the y is, I'll put -5. Where the m is, I'll put -3/4. Where the x is, I'm going to put a 0. And then plus b. -3/4 times 0 is 0. So -5 equals b. Okay, so there we go. Moving on to writing the answer. So this is your m, this is your b, and so the answer is y equals -3/4 x minus b, alright, or -5, and that is the correct answer. Number 29, we have -4/5, comma 2, 11/5, comma 7. So y minus y, x minus x would give you negative 5 over, let's see, negative 15 over 5. That would be a negative 3. So I'm getting a positive 5/3 for my slope, okay? And now let's find our b. We have y equals mx plus b. Where y is, I'm going to substitute 2. Where m is, I'm going to substitute 5/3. I chose to use this point here for no certain reason. And then for x, I'm going to put negative 4/5. Okay? So if you multiply these two fractions together, you will get negative 4/3, which is negative 1 1/3. Bring that over to a positive 3 1/3. So I did this in my head, but I'm pretty sure it's right. I'm getting 10/3 for b. If you bring 4/3 over, make it positive, and that is the correct answer. So your answer would be y equals 5/3 x. That's your slope, plus 10/3. That's your b, or your y-intercept. Okay, moving on to number 30. Let me get a drink here real quick, and we'll continue on. Okay, guys, here we go. Okay, y minus y, my ordered pairs are 3.3, comma 5.6, and my other ordered pair is negative 4.7, comma negative 1.4. Okay, y minus y, that's going to be 5.6 minus a negative 1.4. X minus x is 3.3 minus a negative 4.7, and that's going to give you 7 exactly up top here, 7, and this will give you 7 down here. So I'm getting a 1 out for my slope. I think, nope, I'm making a mistake somewhere. Let me see if I can find my mistake real quick. I think you get an 8 down here. Yes, you get an 8. So I'm trying to go a little too fast here. So there's your slope. Now, y equals mx plus b. 5.6 for y. I chose to use this point here for no certain reason. Your m is 7/8. Your x is 3.3 plus b. I'm going to go completely calculator mode here. I'm going to take 7/8 times 3.3. I'm getting out 2.8875. So now I have 5.6 equals 2.8875 plus b. Bring that over, make it negative, and you get a positive 2.7125. And it would be positive, so your answer would be, this is your b right here, so your answer would be y equals, your slope is 7/8, so 7/8x plus 2.7125. And there you go. That's it. Okay, that's a pretty good stopping point in the video. I'm going to go ahead and pause this, and I'm making this on Saturday, so I'm going to get a little breakfast here and come back and make part 2 in a little bit, okay? So we're going to have part 1 and part 2 on the review sheet, okay? So when you get to this problem here, number 30, and you want to watch the rest of the video, please make note, there's a part